Okay, welcome, welcome. We are going live. We are live. And we are alone right now. Naturally. But of course, you might be watching it on a recording, in which case, hello from the past. As per usual, I'm just trying to figure out how all this stuff works. How can I even... Oh, there we go. Hello. Hello, Ro. Good to see you, my man. Hope you're well. Where are you, by the way? In the UK, I'm pretty sure, if I remember. Isn't that so? Is that you, Andy? I think I remember that is you. Is that right? Good to see you, my man. Are you sticking around? Got yourself a brew? What are we drinking? As per usual, I am on the Red Bush with milk. Cow's milk as well. Old school. Well, the Red Bush is not very old school, is it? But old school and new school mix. Cool. Well, you know, we can just chew the fat a little bit. We'll see how many more people show up. I don't think there'll be too many, but that's okay, because, you know, we're just sitting in the bar, drinking our tea, and having a good time. So tomorrow, the ARG guys are doing their big festival, their first annual festival over in West Virginia. And of course, it's a long way away from most of us, but they do have a Spectrum section. They're big Spectrum fans. And they're going to be doing a live stream, playing some Spectrum games and stuff, as far as I know. So, yeah, check that out. It's Amigos Retro Gaming. That's twitch.tv/Amigos Retro Gaming. Good guys. And they are going to be playing, I think they're going to be playing something that I've done for them, which is like a hack of Attic Attack. And so I figured we could do a little bit of that today and just talk about a little bit about Attic Attack. I've got the source code for it, so we can definitely do that. And what I'll do is make sure that it's working and everything. I need to just check my setup as well, because right now you can't see a damn thing, can you? Right, so there is our source code. That's a big window, so let's patch that up to there. Tidy up a bit. Move my ugly mug down a bit, maybe. Okay, I guess that'll do. Yeah, well, indeed, Ro, behind the scenes of any Ultimate game, it's fun. Yeah, they are fun because, well, you know, they're very popular, and of course, at the time, anyone would tell you, you know, I mean, when you first saw the jetpack, you just couldn't believe it. Really, it was like another level, you know. And it's interesting because before that, I mean, obviously you had the C64, but even then, quite honestly, the games on the C64 in 1983 were still, as I remember, my friend had one, and they weren't that great. You know, I think there was one or two games that were good, but they weren't the kind of games you see now. You know, and the graphics weren't too special either. And of course, there was a whole load of other different PCs home computers, let's say, HCs, that were popular at the time, and nobody had really kind of got a big foothold. I used to go to this computer shop in my hometown, and they had various computers set up. They had a BBC, and they had a Dragon, which I had, and they had Spectrum and a few others. And I just remember that they were all kind of more or less equal. One computer had a good, like the BBC had those arcade games that were quite good and quite colourful and so on, right? They were all, there's like a Donkey Kong on the Dragon and different things like this. And so they were all kind of equal. But then, when we got Jetpack, it was like, bloody hell, excuse my French, but it's like a whole different level, and suddenly everybody was like, oh yeah, let's get a Spectrum. We need to get a Spectrum now. That's the one, and it was either let's get a Spectrum, or oh no, I should have got a Spectrum, And to be fair, some of those other computers did rise to the challenge a little bit, and of course, that continued for a few, maybe another year or two, but eventually the Spectrum became a real sort of games powerhouse, didn't it, really, in the UK anyway. And I think a lot of it was to do with that, really, to do with Jetpack, and I guess Manic Miner as well, the Spectrum had a lot of memory, so you were able to put like 20 levels, which at the time was pretty remarkable. Of course, the Atari range, the Atari 8-bit range, was also out, but as I remember it, it was never that kind of hot in the UK. Not at that time, anyway. They didn't have one in the computer shop up in Barrow-in-Furness, where I was, anyway. It was mostly. In fact, I'm not even sure they had a Commodore 64. I think it was mostly British stuff, and certainly there was a Dragon and a BBC and a Spectrum. And I remember people would come in, and there'd be me and a couple of other kids. We'd be the only ones who actually knew how to do anything on them. And because I had a Dragon, I was in charge of like demoing the Dragon and doing sort of basic graphics tricks and things on the Dragon, trying to make it, trying to impress people, to encourage them to buy it, even though secretly I probably did still want to have a Spectrum. But there you go. But the Dragon does have a few good games, obviously, being based on the Coco, and there's a whole scene for that as well. And there are some good games. The graphics are a little bit limited, but then so are the Spectrums, really. And then, of course, there was another big hoo-ha, wasn't there, in '84. Again, I can remember this at the time when Attic Attack and Lunar Jetman came out, and it was kind of like, wow, they're not making 16K games anymore now. And some of my friends had a 16K, and they were like, oh no, I'm gonna have to get an upgrade and all this. But it was absolutely worth it, wasn't it? It was a fantastic game, Attic Attack. I personally think that it's really the pinnacle, really, of ACG, so to speak. I mean, Saberwolf is good, and Nightlore, of course, is like an amazing kind of tech demo game, if you like. But in terms of longevity, right? In terms of stuff that I would still play as a gamer, right? First and foremost, not as a Spectrum fan, but just as a gamer. then I would still play Jetpack and I would still play Attic Attack, but I wouldn't play Night Law. Saber Wolf just doesn't. At the time, I really enjoyed it, and I thought the graphics were amazing and everything like this. But it's a pretty kind of it's a bit one dimensional, really, and frankly, a lot of the later titles they did were like that. It's just my opinion. So if you prefer the later ones, that's completely your call, isn't it? But that's for me. And the thing I like about Attic Attack is the fact that it kind of there's some elements that are random where the keys are in different places and things like this. And you can play as 3 different characters. That was pretty unique at the time as well. And that just gives it enough variety so that each time you play, you can kind of get a different game out of it, right? And so even though you can finish it, and I like many of us, I figured out how to finish it in only 5 or 6 minutes if you had a certain combination of the right places and so on. And and I did a mod for it in 2019, I think, or maybe 20, where you could play as Saberman instead, and you had to collect all the items. And in testing it, then I had to play the game quite a bit more and get to know the mansion better. And the more I did, I found it's a really fun game for a speed run. You sit down, have a bit of fun. There you go. And that the whole thing with the food, the way that it slowly runs out, and you're always up against it. It's a kind of survival element to it. And again, that was quite innovative, and I think that's another reason why I personally think it was the kind of high watermark really for the Stampers. Andy, right? Yes, Night Law. I again, for nostalgia, I'm not big on nostalgia, but I know you guys quite like me to reminisce and tell a few stories. But I do remember, because I moved to the Middle East, right, in 82, 83. And I took my Dragon 32 with me. And then in 84, we used to go back to the UK for Christmas, and I got a Spectrum with Night Law. And the reason I got it is because a friend of mine had a Spectrum, and he got Night Law. And he came back and he said, I've just seen the game with the best graphics that I've ever seen in any game ever. He's kind of, maybe he's a little bit prone to exaggeration, but and I said, what are they like? What is it, like 3D? Is it like what is it like? Probably didn't say sprites. I probably didn't even know they were called that at the time. He said, no, it's like I've never seen it before. It's like a sort of difficult to describe. It's a kind of, it's like a 3D square area, and you can sort of move around, and it's like everything can go in front and behind, and wow, I just can't believe how good it is. And so I just then said I want to get it, so I got it. I just got it on his recommendation, and I did really like it, but again, I would say almost all of those games are really good at the time, but when you look at them now, they're it's just annoying. There's too many annoying things in those games where it slows down, and the thing where you turn between a werewolf and a human is clever, but it's not very well implemented. Really, it becomes annoying. Personally, just personally, and obviously then people took that idea and did it better, didn't they? As well, there were other games that improved on that, but just in general, I think in the end it was just too slow, right? It was just a bit dull, a bit boring, and a bit slow. But amazing technical achievement, and so it has to be praised for that, but of its time. Whereas, as I said, I can happily play Attic Attack even today, and have a bit of fun with it. So Yeah. Let's jump over and have a look at the source code. Let's just test it out. We'll bring the emulator up as well, and don't have a right. I'll just check on the stream that we're in the right place for this. Okay. Yeah, that's alright, isn't it? I'm always getting these windows and talking about stuff and you guys can't see it, so I'll try and keep a track of that. Yeah. Okay, so yeah, this is Attic Attack, which was as you can see, it's a disassembly which was done by Obo, so shout out to him. Obviously he made a few small changes. There is a protection on the game to stop it being copied. Not sure how that works, but yeah, made a few changes, and there was a typo which he fixed, and a couple of other small things. And I've also then added here, this is in SGSM Plus, and here I've got an option. Well, you can see this one is Saberman, which puts Saberman into the game. This one is Fix128, which, if I look for that, I'll see that it's to do with the 128K machine. You can see here this out here. So what this does, if you've got it on a 128K machine, it actually it swaps the shadow screen into memory. And so you end up with this black screen when you try to load it on a 128K machine. So obviously the 128K machine wasn't out when this game was made. So yeah, there's a couple of basically out in assembly as a way of communicating with ports. And when we say ports, we don't necessarily mean like a joystick port, although that is included. It means communicating with anything external to the CPU, really. So there's something there that controls the bank switching, something like this. So got to be honest and say I don't know the 128K machine that well myself, but anyway, let's assemble this and make sure we can get it right. So just a minute. Okay. At the moment, I've got it assembling as Attic Amigos, right? So I'll just put Attic Attack O there, and this will assemble it and make it start. It'll create a tap file, and it will assemble that and build it into a tap file, and then it will create a basic loader, a simple basic loader that will launch it from start address here, right? So yeah, theoretically then, if we assemble this, there we go, that's all okay. And I need to remember where it is, so hopefully it's going to be here. Okay. Yeah, just bear with me, guys. I'm going to go to where I think it is. Yep, I just found it. Right, there you go. Right. Now we might need to do a little sound check here, but this is the standard one. And are we running in 48K? No, we're in 128K, right? So you, in theory, we'll see why this won't work, right? Because it's in 128K. There you go. So there you see it's just frozen and jammed up, and you've got this blank screen because it's sent a command to something which the 128K doesn't like. Simple as that. Okay. Still with me, guys? All good? Do we have any new people joining? Hello, if you are. A couple of lurkers there, I think. Shout out, say hello, don't be shy. So yeah, and then well, just to show you, I mean, what we'll do is I'll switch to 48K, right? And presumably we've still got the tap in there, right? And that should work now. There you go. Now I need to apologize because there is a terrible problem with my speaker, and I actually think it's a problem with the laptop, because for some reason the sound just obviously it's not authentic, is it? It seems to cut out at certain levels, and I don't really know why that is. It's a second-hand laptop that I bought and everything seemed fine, but I suspect that maybe that might be it might be an actual hardware problem, unfortunately. So who knows, and that's why you got, I'm guessing you got that horrible sound then, right? It just went something a lot worse even than the normal Spectrum beeper. So yeah, so you can see it works there. And then if we go back to the source code, right, which you guys can see, yeah, okay, so this is the source code. And there's a fix that I've done there. It's the same as the other one on that you can do on Jetpack and others, right? So just to explain, in STSM Plus you can set these kind of constants, right? They're basically fixed values that you can then use and you can test within the code. So it allows you to have variables, if you like, that are not variables for the actual code but for the script, right? So it means, for example, then just to show you what I mean, you see, if I set Saberman to 1 here, right, and in the code you'll see, for example, here, if Saberman, then it's going to change the option here to say Saberman instead of night or whatever, right? And then it'll also change the graphic, you know. So you've got I've got some external code here for Saberman, where you have to collect all of the items, not just the key. And then you've got here, yeah, I made a slight change to the food so that the food replenishes a bit more often, because you've got to spend a lot more time. And then if you look here, you've got this sprite table. You can see here there's a lot of stuff about Saberman left, Saberman right, and so on. So I've changed the addresses. Remember, all labels in assembly are addresses, right? They're just addresses in memory. So you can see they're all mentioned here. Let me just jump to there. You see, so this is the graphic of the Saberman, and each one of these represents 8 pixels, right, across 1 byte. And so 1, 2, 3, 4, 5, 6, 7, 8, of course, so he's 8 across there. Well, he's probably not 8 across, probably 2 lines that represent him there. But and up here you've got, this is his height, right, and that's in hexadecimal. That's 16 in hex, so that's 16 plus 6 is 24, right? It's because in hex 10 is 16 plus 6, so 16 plus 6 is 22, isn't it? Not 24. There you go. Okay. Yeah, so that's how they actually do the graphics. You can have varying heights of graphic, right? So yeah, I might as well just assemble that and show you that first, right? I think did I let me just check if I did set Saberman to be on. Yeah, and let's fix the 1 to 8. So what, you know, you might have like 3 or 4 different points in the code where you need to fix this bug, right? It's not really a bug. I mean, it's because they didn't know, but it's a patch, right? We want to implement a patch to fix a crash. So what that actually does, what you can do then is you can keep the original. So if you want to assemble and have the kind of vanilla Attic Attack, then you can set all of these to 0, right? And then it'll just create the regular one. And then you can enable certain things. So that means that you can keep the original, and then when you've got something that you've added, then you can just remove it to see if what you've done has crashed it or whatever, you know. And it's just a way of being able to keep one single source file, but have options for yourself to do lots of different things. And essentially that's what I do with AGD, right? With AGDX, let's say. There's a lot of different patches and different code that I can add in, and it's there are ways that I can just switch things on or off that basically assemble it to give different options like AY support or the panel code and various other things like that. So anyway, let's just switch on Saberman for now, and we'll switch fix 128, and let's hope that works. Okay, yeah, we've got no errors. Let me just check. We've got anyone saying hello? Just a quick check. How are we doing? 5 people in here, but I don't know who else is here apart from Ro and Andy. Seems like there's. Do I count? I guess I count as 1. So, so it seems like there's 2 other people. Welcome anyway. You're welcome, even if you're not going to speak. But do say hi if you'd like to. You'd be very welcome, because it's all about meeting new people. Hello, Stunik. Nice to see you, sir. And where are you this fine evening? Fine morning, fine afternoon, wherever you might be in the world. I'm guessing probably in the UK. Most of you are. So I'm just pouring some tea here. Yeah, you know, the thing is, I like doing this stream, and I like doing the coding, and I know that you guys quite enjoy just watching me do my thing and chatting about it. But it is nice to get a little bit of feedback, you know, while you're watching. Just chip in and ask questions and do that. Makes it more fun for me, makes it more interactive, which is what I like. You know, it's why I do it. So you know, give and take, guys. Yeah? Right. So I think I assembled it. So let's set the machine to 128. Right, that should reset it anyway. It's on pause, isn't it? And again, we'll see. I think what I might do is just turn the audio off, if you guys don't mind, because if we haven't got proper audio anyway. Okay, good. Birmingham. I've been to Birmingham. Actually, I've been to Birmingham, Alabama as well, believe it or not. Ain't no ham like Birmingham. I'm not sure which one I prefer, but I've got to be honest and say that neither of them are in my top 10 cities in the world that I've been to. You know, but I'm sure they all have their charms, you know. Let's see if that works in 128 now. It should do, shouldn't it? No. Interesting. Well, this might be some old code. I don't know. Maybe I haven't assembled. Maybe I didn't assemble it. Let me just make sure I did. Because also we didn't see Saberman, did we? So perhaps I didn't assemble it. Okay. This is live coding for you. Right, there we go. Look, there's Saberman. And as you can see, he's a little bit taller than these guys. And as a result, he's kind of sort of started to bleed into that little bit of yellow there. So not that that really matters though, does it? Yeah, so we should be able to just go into keyboard and start. Horrible keys, aren't they? But let's see. Yeah, look, that works now, right? That's some 128K, so that works, no problems now. And there's Saberman. I think I gave him a. Yeah, I mean, I couldn't give him his kind of fighting sword, you know, because he kind of walks around with his little sword and he's sort of wiggling about. That would have taken up a lot more memory, but he has got his fighting sword that he throws. So he is essentially in the game, right? Cool. All right. So let's talk about how we do it. When you've got the source code, it's a lot easier, right? So let's say, for example, when I was working on very nice, Stunik, thanks for the follow. Good. I don't know if do I know you from, would I know you from Facebook or somewhere by a different name? If so, let me know. But anyway, good to see you. Yeah, so back to what I was saying. Yeah, let's say, for example, I've done some different mods or hacks where, for example, like Bruce Lee, right? And I haven't got the source code. Now, at the time, I wasn't that hot on assembly, and well, I'm still only lukewarm now, but anyway. So what I had to do was just kind of go through not the source code, but the actual binary, and figure out where the graphics were and how they were stored. So that's quite a laborious process. You can use things like hex editors, and you can use things like you can sort of save off parts of the memory and then try and figure out how the graphics are stored and various things like that. But as you can see from this one, if we look at the Saberman thing here, just a minute. I just need to do a search for that on the source code. Looking in the wrong place. Just a minute. Okay, you see where all of this is orange. It's because it recognizes. There's a command in Z80 that uses an apostrophe, so it thinks all of this is in speech marks. So what I do is I'll just comment it like this, and then I just added a comment with a second speech mark so that it would make this a little bit easier to read. So this is a really nice source code. Someone has gone through and disassembled it and figured out a lot of how it works and put a lot of comments in and everything else. So it's really makes your job a million times easier, and it's a lot of work to do a disassembly. Some people enjoy it. Obviously, it's a real one. If you do it, then you really understand the game, don't you? So that's one sort of benefit that you get from it. I mean, I find that to be a little bit laborious, but as I said, some people really enjoy it. Yeah, so for example, right, you've got here is like the knight, yeah, and there's his graphic, and you can see I've got a setting here for Amigos, which is change the graphic to those guys from that channel to give them their own graphic, right? And it says if we've got Amigo set, then do this, and if we haven't got it set, then do this, right? And this is the knight's graphic here. Now, as I said, the way that the Ultimate games worked, all of the early ones, well, certainly up till Attic Attack anyway, I don't think, obviously, the 3D games, well, they wouldn't be like this, but the 2D ones more or less work like this, right? They have an address where the graphic is stored, right? And then they put all of that into an array, which you can see somewhere up here somewhere, I think. Let me see if we can find it quickly. No, that's the map there. It's been a while since I looked at this one. Yeah, right. So you see here, for example, right, it says sprite table, and you've got all of these different definitions of all the sprites, right? And each one of these will be, it's like an ID. It's like an ID number, right? It tells you. So for example, that means that sprite ID 0 here, ignoring this Saberman bit, right? It would start from here, right? So sprite ID 0 would be the knight left, and then the next one would be knight left 2, so a knight left 3. So it's got 3 frames of animation, and then you've got knight left 2 again, right? So what we can see from that is that it's defining those sprites at those addresses with an animation that's going back and forward, right? So you've got frame 1, frame 2, frame 3, and then for frame 4 we just repeat frame 2 again. That's really common in animation. Andy, you'll know about that, right? So you start with your man like this, and then like this, and then like this, and then back to this again, this middle one. So his feet might be in the middle like that. So you go 1, 2, 3, 4 like that, right? And you don't need to define that 4th frame. You can just use the 2nd frame, right? And I think you'll see that same pattern again here. Yeah, look, you see you've got the wizard left 2 and then left 2 again, right? So if we altered that, which we can easily do, right? It's just purely as a demonstration, right? So let's say, for example, if we just put wizard left 1, wizard left 1, wizard left 1, wizard left 1 like that, then theoretically, when we move the wizard to the left, he'll only have 1 frame, won't he? We'll see. Okay, just a minute. Oh yes, oh good, right. Well, welcome Stuart, and thank you very much for your support. I really do appreciate it. And although I don't often know some of you guys personally, it really does help. It really makes a difference. And one of the reasons I do the stream is because I was hoping that some of you guys might pop on and we'd be able to kind of interact a bit more. So yeah, cool. So anyway, let's go back and we switch the Saberman off, and we've kind of messed about with the wizard graphic, so we haven't got any errors. And let's go back to the tap here and load that in. Okay, and take it off pause, and we should pick wizard and see what happens. Hope this works. Here he comes, right? There he is. Yeah, so look, there you go. You see what he's doing now? He's only got one he's only got 1 frame, so he's chugging along nicely that way. But when you run him that way, he's completely stuck, isn't he? So yeah, that's a nice demonstration of that, right? So what you've got there is like a list of it's like a frame list, if you like. Sorry, we're going to cancel that now, obviously. Just a minute. Right, so we want to just, yeah. But it'd be interesting because I mean, theoretically, right? If you look at what have we got here, for example, right? We've got, let's see, what should we do? We've got spider 1 and spider 2, right? So let's do that and see what happens, right? So if we change the wizard to spider 1 and spider 2 like this, and then spider 1 and spider 2, and then we should really, well, okay, we'll just do it like that. We could do it for left and right, up and down, all of it, right? But well, actually, you know what, I think we probably could, right? So what we'll do, right, we'll comment out. We've got 1, 2, 3, 4 addresses, right? So we'll comment those out. You just put a semicolon in, right? And it'll ignore that, right? And then what I'll do is I'll just repeat this 4 times, right? Like that. So what I've done, yeah, Andy, just to answer, well, yeah, well, I'll explain clearly. What we've got is, so imagine you've got all these sprites, right? But in this example, in this game, or in whatever game that you might be playing, if you've got sprites of different heights, yeah, then obviously the data is going to be different sizes, yeah, and in a game like this, it's very flexible in terms of the height, because you can have a sprite of 3 or 4 pixels or 16 or something like this, right? So when you want to find the address, the source address of your code, then and everything works. Everything in Z80 is just addresses in 16-bit, right, or numbers in 8-bit. You see how it says here DW? That means define word, and a word is essentially 2 bytes, right? That means it's an address rather than a single byte. So in each case here, we've got 2 bytes which put together form the address of all the different frames, right? And this is all the frames of the whole game. You can see, look, you've got everything. You've got the Hunchback, you've got the whatever, right? So by doing that, you put them all into a table, and effectively that means they're all 2 bytes, just the address, right? And that means that it's all uniform, right? And that means, therefore, if you want the night, you look at point night left is 0, and then you add 2, and it's to the left, and you add 2, and you get the address for the next one, and you add another 2, and so on, right? So you can easily find any frame that you want, the address of the source of the frame, and that's how you can work around the fact that you've not got a uniform size, right? So, for example, in AGD, you've got a uniform size of sprite, so therefore you can easily calculate where any frame is, because they're all the same size. You just have to add the size of the frame, and all the frames are the same size. But in this case, the frames are all different sizes, so you just use a table, and it's just a lookup table. It's just a reference. It's like an index in a book, right? Look on page whatever, find that's where you'll find this, and it's a nice long list like an index, where you just look down and you go like that, and obviously, just as a human can use an index really quickly, so a processor can do that as well, right? So you can easily find the source for that. And what I've done here, just briefly, is I've taken out. I can see I've got GWizard here, right? So now, hopefully, this is going to be fine, because it will look up. It will try to find the graphic for the wizard, right? And it won't find, and instead it will be pointed to the spider, right? So I've never tried this before, so we're flying by the seat of our pants, really, but it's the best way to fly, I think. And in theory, once we run it now, once we assemble it, and then when we pick the wizard, we'll see what happens. But we should just get instead of the well, look, there you go, look at that wizard. There he is, right? So that's kind of cool, isn't it? Right. So interestingly, that tells you, that they take the graphic for the menu as well and put it in there, so it's not a separate graphic or anything, right? So we pick the wizard, and we'll see what happens. So press 5. Okay. And it's going to draw it back up like this. There we go, and look at that. We've got a... That's pretty cool, isn't it? That's fun. And there's his mate, look there. Look. Right. Spider adventure. Yeah, I could release it. Yeah, basically put all the monsters, play as any monster, and play as the bat, play as the witch. Let's see if we can get a witch. Play as that random ghost. Yeah, she goes left and right, doesn't she? Look, the witch. So that would be quite fun as well. In fact, why not? Why don't we do that? We'll do it quickly. just it's a nice way to review what we're doing anyway. So yeah, and it is fun, Stuart, and you know what I hope to do as well with you know with this stream is just to show you that it's, you know, it's not magic really. It's just some fairly straightforward principles, and I know I've said this before, but it's a I enjoy the metaphor, if you like. The idea that when you get the bus, one night when I was going home, I missed the last stop on the bus, right? I missed my stop, right? And so I fell asleep and I missed my stop, and I woke up, and I looked around and I had absolutely no idea where I was, right? And I was like, oh bloody hell, where am I, right? And it was past midnight. I lived in East London, and I was a bit worried, you know, because it's not the most savoury of districts, you know, and it's all gentrified now, but this was you know 20 years ago or something, but and I had absolutely no idea where I was, you know, and then so fortunately I asked someone, and they said, oh yeah, you only missed one stop, it's just up there. It was walking distance. My house was walking distance, and the point that I want to make from that is that what you don't know seems completely alien to you, but it's really not that. It might not actually be that far away, right? It might seem like a completely alien place because you just haven't been there at all, but it really could just be around the corner. And in many cases, when you learn assembly, it's really, if you know a bit about coding already, it's really not that far away. It's just that you don't know it, right? That's all it is. It's not that difficult. It's just different to what you already know. But yeah. Anyway, let's mess about, and what we're gonna do? Stop messing about. Right, we've undone that. Right, what are we doing? The witch? I'll let you guys, you shout it out in the comments there. Let's get you guys to be a bit more interactive. Yeah, okay, let's look. What have we got here? We've got the mummy, we've got Frankenstein, there's the devil, there's Dracula, there's a witch, there's the witch there, and then she got witch L2, yeah, witch L1, witch L2, R1 and R2, so she's got a left and right. There's a monk, there's a bat, which all seems to also have a left and right. There's a hunchback, he doesn't have a left or right, but we could use him. Sparkle, blob, ghoul. Well, you're gonna call it out, boys? Call it out. Tell me which one you want, and we'll do it once again, just for the crack. Okay. No one speaking up. I know there's a bit of a delay with. Okay, try the witch. Okay, 2 votes for the witch. It only has left and right, yeah, which is fine. I mean, I don't think any of the enemies have up and down at all. I'm pretty sure. Dracula, Frankenstein, no, they're all just. Well, most of them don't even have left or right. Most of them just have animation and whatever, but the witch does have left and right. So, yeah. Let's see, there she is there. G-Witch 11. Yeah, well, that's what I did. I'll show you again, right? So we'll do it one more time. So you've got the witch there, and what I might do as well, just for fun, is I might put the wizard in the place where the witch is, right? So that we can have the wizard kind of spawn. as an enemy, right? So yeah, look, you see here you've got wizard left there, and then you've got 4 frames wizard right, 4 frames wizard up, and 4 frames wizard down, right? And just as an additional thing to say, by defining them like this, they're also saving a bit of memory, right? Because they can use, they can just reference. You see there, you've got those 2 are the same frame, right? So you're not going to be using 20 bytes or whatever it is for the wizard for each frame. You're only going to be using, well, you're basically saving 1 frame because you're repeating 1, right? A little bit like with what Andy will know about is I wrote a little script with AGD where it flips, where it does a bounce on the frames so that you can put a frame in the middle, and then you don't need 4 frames of animation, you can use only 3. So yeah, similar thing. But when you say would you just use left or right, what I basically did then was I just took the spider, there was a spider left and spider right, and I just replaced all of it up and down as well with the same. So when it looked for the up and down graphic, it just used the left and right graphic anyway, right? So that's what we did there. Yeah, no, that's all right. That's why I thought we'll do it the second time just for fun. So we know that the graphic of the witch is here. Okay. And she's just called gwitch L1, gwitch L2, and gwitch R1 and gwitch R2, right? So let's yeah, we'll use the wizard because he's got that fireball, and the witch has a witch throwing a fireball is a pretty natural thing, isn't it? Right. So we've just removed the wizard there, right? Those definitions. So all we do then is we just define DW, define word. You can also write def word, which is what I normally use, but it understands both anyway. Okay, so that's left wizard witch left 1 and witch left 2, and then we want to just go witch left 1 and witch left 2 again, right? So instead of 3 frames, we'll just have 2 that go back and forward like that. Okay, and then we want to do the same thing again for the right side, like that, and then we'll just repeat it, yeah, for the up and the down, and that would mean that when she goes, might look a bit weird, but can't really do much about that. It'll be all right. When she goes up, she'll turn left, and when she goes down, she'll turn right. And yeah. So when she turns left, she'll turn up, and when she turns right, she'll turn down, and when she turns either left or right, she'll be neither up nor. Anyway, never mind. Let's get on with it. Okay, so that should be enough, right? But let's have a bit of extra fun with it and just let's put the wizard in instead of the witch as well, just for fun, right? Okay, this has worked out pretty well. This is quite a fun little beginner level sort of stream thing to do that has a nice result. So we'll put the wizard left in there, wizard left 1, and wizard left 2, and well, I hope I get this right. I'm guessing that this one is going to be wizard right 1, right, instead of just R1. Yeah, look, you see if I don't know if you can see that, but it's come up with a little prompt telling me that yes, that is a label that exists in the game. So, and then we'll say wizard right 2. So he's only got 2 frames there. So the animation's probably not going to be very good, but it's just for fun, isn't it? So let's try and assemble that one, right? And after this, I'll show you how we can do our own graphics and add them. Yeah. So let's assemble that. We'll go in. All right. There you go, and look, there she is, sitting there. Yeah, and you'll notice that she's drawn correctly because the height is stored in that address, right, that I've pointed to. So it gets the height, and then after that it gets the data. So therefore you can just pick the wizard, and hopefully, if that works. Yeah, there we go, right? So there she is. And yeah, look, you see how she turns around when she's going up or down, which is, you know, not ideal, but yeah. Now, of course, if you wanted to, if you were so inclined, I mean, I don't know how much, I don't think there's that much memory to play with, right? But, you know, you could replace the graphic of the wizard with the witch, yeah? And then you'd have some... then you could, you know, potentially add an up and down graphic. You could draw your own in there if you wanted to. So she would actually go and fly up and down. Is she actually animating? Yeah, just a very subtle animation that Mr. Johns would appreciate, I think. Right? There's very little... you could do better than that, Andy, couldn't you? Let's be honest. You could do better than... Who was it, Tim or... Chris Stamper, I can't remember who did the graphics. I think it was Tim, but that's, I'd have to get, I'm guessing. Yeah, it's kind of cool, right? You could, I mean, if you really wanted to, if you know, you could start thinking about other things and make this into a whole game with this witch and give her different things to collect and, you know, change the map, and it could be all kinds of fun, couldn't there, really, to be had? Yeah, the devil is. Come on, I'm a witch. You're the devil. We should be friends, no? Oh well. Yeah. Okay. Good. Cool. Let's move on. Talk a bit more about that. So let's just cancel what we did because I don't want to leave that in there permanently. Okay. And we are back. I tell you what, Andy, if you want, you could always send me a Nixie sprite in on an on a screen format, because you could use the ladder up and ladder down. I don't know. Maybe you could actually. We could do that. You've got, you know, well, ladder. The graphic for the ladder would be her going forward, right? I mean, upward, up the screen, right? And then I'm sure you could just mod it quickly and give her a face or something, right? Yeah, you could do that if you want, and then we can talk about how we do it. Yeah, but you know, you haven't done one facing. Well, yeah, I reckon you could do it in a New York minute. Okay, so it just so happens that I have a little 10 minutes. 10 minutes, boy. Come on. Or did you mean 10 seconds? In which case, that I would be impressed. 10 minutes. Remember, it's not an actual game. We're not releasing it or anything. It's just a bit of a laugh, you know. It's very, very precious about his graphics, though, Andy is, you know. Believe me. We've worked together on plenty of games, and he's very precious. But he's very precious to me too, so that makes it all right. And we like sticklers. in 8-bit land, we like sticklers. Sticklers make the best games in the end. Okay. So, right. Let's continue. Right. So, what I want to tell you about ACG, Ashby Computer Graphics. You may remember that in a previous stream, I spoke about the chasing the beam, you know, the raster beam, and how you can avoid flicker. And what they tend to do in their games, and certainly in these older games, is they draw all the graphics from bottom to top, right? And the idea with that is that the beam's coming down, and you're drawing it upwards, so you don't get as much flicker. I think that's the theory behind it, anyway. So all of the graphics in the game are actually stored from bottom to top, so to speak, right? And I can actually demo that. So I think I've got a little thing in here, and we can actually talk a little bit about a simple assembly routine. Okay. Okay. So this routine here, and I won't cover all of it, but I will explain some of the basics for you guys, right? So you're interested. I won't cover the entire thing here. This little bit here, you'll have to kind of take my word for what it's doing, but I will explain it a little bit anyway. It's a very simple routine, and what I can do with it is I can take some graphics from within the game, and it's a small routine that will just display them, right? So let's say then if we wanted to see the wizard, the wonderful wizard of Attic Attack, then right, we're off to see him now. Just a minute. G-Wiz, G-Wine, there's the wine. G-Wing. Okay. Okay, so let's say we're going to change the wizard, right? In this case, I've set it as Amigos, right? So we'll have to change it to something else. But okay, well, let me just see. So there's quite a lot of graphics that we'd have to change, but it won't take that long once we've got them in there. So okay, let's start with this one. For example, I just want to show you how it works really for now. G-Wizard down there, right? And G-Wizard down, G-Wizard up. So this is all the raw data for the wizard. Right, so that's pretty much all of it. So I'm going to take that and I'm going to put that raw data into this routine here, right? So that I can then tell the routine to basically draw it. Okay. So what you've got here, and I'm going to open up ZX Paintbrush in a minute so that we can see how this works. But before we do that, I think we'll just run it and we'll make sure it works. So I want to start there, and I've got, this is an address. Remember, all of these labels, all they do is point to an address in memory, right? So we'll go here, and this is where it says, you see here where it says draw sprite, right? So instead of putting the address of the sword, which I was looking at earlier, I'm going to put the address for the wizard there, right? Now, again, if you haven't watched the other videos, the CPU has... Oh, I just had a call from Aaron then, but I think that was a mistake. Yeah, that was Aaron from Amigos sending me an accidental call. Anyway. So, where are we? Where are we? I've lost my thread a little bit. Right, we're back here. Source code, yeah? So, inside the CPU, you've got a tiny, tiny little bit of memory, right? Which is called registers, and they can store 8-bit numbers. And those registers, the simple registers, are the accumulator, which is used for maths. And then you've got B, so we call it A for accumulator. Then you've got B and C, and then you've got D and E, and you've got H, and you've got L, right? So it stands for high and low. And then B, C, D, E, I think they're just alphabetical, right? Okay, and you can use those in pairs. You can join them together, so B and C can be joined together, and D and E can be joined together, and H and L can be joined together. And by doing that, that allows you to do 16-bit, and that is 16-bit addressing, right? In this case, so that we can point to a particular address in memory from 0 to 65535, right? And so, in this case, for example, you see here, you've got this 16-bit address here, org C000, right? So that is, I think that's 49152, something like that in decimal, or is it 32? I can't remember. I think I'm right. Should know, shouldn't I? Just off the top of my head, but yeah, 49152. I'm right. So that's up in the higher memory, and just out of the way really, because I'm not. It's a small program and there's nothing in the way. So yeah, but that address, if I want to store that address in the CPU registers, then I can store that address in one of the register pairs, right? So for example, you see here I've got 16384, right? So that in hexadecimal is 4000. And what that means is that H will then have the value 40, that's the high byte we call it, and L, which is the low byte, is going to have the value 00. Yeah, and the way that works is, I'm not sure if it's the calculator on the screen there. Yeah, it is actually. Yeah, look, there it is. I'll bring it up so I can show you. So C0, for example, right, in decimal is 1192, right? And because that's the high byte, you multiply it by 256, right? The reason it's 256 is because 2 to the power of 8, remember you've got 8 bits, so this will be the 9th bit. So 2 to the power of 8, and so therefore it's multiplied by 256. This is why you hear the number 256 a lot. When you, within the 256, it's an 8-bit number, 0 to 255, right? As soon as you hit 256, you're going to need an extra bit, and that's when you need a 16-bit number. So 192, if I multiply it by 256, you'll see it's 49152, because in the source code you can see C0 and 00, and that means H has the value 192, which is C0, and L has the value 0, right? And so you add those two together. This one plus this one makes a 16-bit number, and that's how you know. That's how you can basically navigate, yeah. And I've said this on my videos before, but if you're not sure about how memory works on 8-bit and 16-bit systems, yeah, thanks Andy, good, you've sent it to me. I'll have a look at that in a minute. Hopefully we'll bring that up and we'll see what we can do with it. So the first bit, it's like a house number, And the second bit, then imagine you've got 255, 0 to 255, so 256 houses on the street. It's a long street, yeah. And then this number here would be like the street name or the street number, if you like, right? So that would be, in memory, you've got this huge grid, and each one is a page, 256, and there's 256 pages, so the whole thing makes 65535, right? So, and remember, everything is addresses in memory. All of these things are all these labels, they're all addresses in memory. They're not line numbers, nothing like that. They're just purely addresses in memory, and they can be stored in 2 bytes like that. And they can also be held in the internal CPU in the registers, where you can then perform operations on them nice and quick and so on, right? Okay, so what are we doing here? Well, what we do first is we put the address of the wizard source into registers D and E, so that we know we can then reference where the wizard is. And then in HL we're putting the address, and this is right at the top of the screen memory, so it's going to mean that whatever we read from here is going to be drawn in, or put into memory. We say drawn, but it's not really drawn, but it's put into memory at this address. And then obviously when the ULA comes to read the memory and it sees what we've done as it kind of scans, it will then send the information to the video, and it will appear on the screen, right? And as the raster beam goes down like that, right? So you can watch my previous streams and so on. I'm assuming most of you have, where we explain all of that stuff. But I hope that's all clear so far, right? All good, guys? Yeah? Feeling good? Looking good? Feeling good? I'm running out of tea. I've almost run out of tea, which is a bit of a concern. Anyway. Okay. So at this point, all we've done is said to the CPU, please remember where the wizard is, and please remember where the screen is, because I'm going to need those 2 numbers. And the CPU says, certainly, sir, no problem. Okay. And then the next thing I'm doing here is I'm calling a routine called drawGraphic, and that routine is here. Yeah. So what the CPU does at this point, essentially what the CPU does is it says, oh, you want me to go somewhere else? Okay, well, let me remember where I am, right? And it remembers where it is. It stores it in the stack. I don't need to go into too much details about the stack, but it stores where you currently are in the stack. Remember, it's just an address, nothing else, not a line number, nothing else, just an address. Stores that in the stack, and then it updates the program counter to this address here, and it just changes the program counter to there, which means the next thing that it's going to do is read from here, right? Now, we can talk about this code in a minute, but once all of this code is done, and it will just go down here and do all of this code, right? And then at the end here, you'll get this ret. And when it gets this ret, it will look back at the stack and say, where was it that where was I before you called me to this routine? And it will then get that value, and it will put it back into the program counter, yeah, and then it'll just carry on, right? And it'll just carry on there, and then it'll actually receive another ret, which in this case will send it back to basic, right? But because we haven't set anything up properly, it will just cause a small crash, but that doesn't matter because we just want to see the graphics. You'll get an error, but it's not a big deal. The reason it does it is because we're not running it from within basic. We're just loading it in as a tap file and just running it without setting things up properly, and it causes basic gets confused, but it doesn't matter, right? Because we only need to see the graphic. Okay, so that's essentially how a call works in Z80. It's literally remember where you were, change where you are, and when you finished, go back to where you were, and that's all, right? Just pure addresses, nothing else. Okay? And it uses the stack to do that, which is a way of storing addresses, which we might, well, I'm sure we'll talk about that at another time. Okay, so we've jumped into here, and what are we doing next? We say load ADE, right? So what that means is take the not the address DE, but what is in memory at the address, right? So whatever you have in memory at this address, put it into the accumulator, right? And here is the wizard, and so it's going to read this value here, which we know is the height of sprite. Okay, so that's the first thing it does, and then it loads it into the register B so that we can use it, right? Okay, and the reason we load it into register B is because obviously we want to keep that number, and the accumulator is used for maths and moving numbers around, so we can't keep it in the accumulator, so we'll just copy it over to register B, which we're not using, and we'll be using register B as a counter, right? Because the height in this case is 20 something, right? It's 20, isn't it? Yeah, so 16 plus 4 is 20. So it's a height of 20, and so we've got in register B, we have got now the number 20. Okay, so right now, what have we got? We've got here, we've got in register DE, we've got the address of the wizard, and in HL we've got the screen. In the accumulator, we've got the height of the wizard, and then also in B, we've also got the height of the wizard, right? So we've just copied it over. We can't do this, load B DE. That doesn't exist in Z80, so instead, you have to do it in 2 steps, in this case, with register DE. Incidentally, you can do it with HL, but I haven't done it in this case. You know, I could have done it that way, and maybe I could have put the screen address in DE, and it would have been the same thing, but there are many ways to skin a cat, and I'm not concerned about speed at this point anyway. So, right, and then we go increase DE, and all that does is just adds 1 to the value of DE, and remember DE is just an address. Cannot stress it enough. Everything is just addresses. So that's an address in memory here, and now we've just moved down, and now we're at this address in memory, and we're going to read from here 3C, and then 0, then 4C, then FO, and this is graphic data, right? Okay, now let's count that. How many are there, right? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it should come as no surprise that there are 20 lines there, yeah? And you'll notice that there are 2 bytes per line. So there's actually 40 bytes of data, but there's only 20 lines. So each line is going to have 2 bytes of data. Okay? Right. So how do we do it? Let's take a look. You see here? Where are we here? We've just gone to we've read the height, and we've gone to the first byte that we want to show. And we create a loop, and we call it here draw loop, and that's an address as well. Then we load the byte of data in from the source, and then here load HLA, we put it into the screen memory. That's the first byte. Then we go to the next byte, that's DE, so that's the next address for the next source byte, and then we increase L. In this case, the screen memory will go 1 byte across on the screen. And then we'll do the same thing again. Read the data again, and this time we'll go decrease. Let me just check and make sure I'm doing this right. So read the data, yeah, go to the next one, read the data. Right, so up until this point, up till here, we've printed, we've moved 2 bytes on the screen memory, right? Then we go decrease L, which means go back one step, because what we're going to do is we're going to go draw and then draw, and then we go back and then down and then draw like that, and then down and then draw and then back and then like that, right? So we go 1, 2, and then down, well, 1, 2, and then back and then down, 1, 2, and then back and then down like that, right? So we're going to go all the way down. So you could draw it like this, right? But then you have to rearrange the source because the source is not stored in that order. The source is stored byte 1, byte 2, byte 3, byte 4, byte 5, byte 6. Yeah, and all the time I'm doing this, and I hope this works, I'm doing it mirrored so that as you look at it, you'll see my hands going in that way, right? Hopefully. So. Yeah, we've printed the first 2 bytes, and then we need to go down 1 line, right? So we go back, and then we increase the source. Remember, DE is the source, and then we need to go down 1 line. Now, normally, if we're at the top of the memory in 1 character space, then going down by 1, we just need to increase the high byte, which is what I've done here. But this routine, which I'm not going to go into too much detail, what I will tell you is that what that routine does is it just, because the spectrum memory is a little bit convoluted, right, it checks to see where we are on the screen, right? And so what I'll say is that this first part here checks to see if we are within a character square, in which case if we're inside a character square we don't need to worry. If we've crossed a character square, we then need to increase the low byte by 32, which would move us down to the next character, right? So 1, 2, 3, 4, 5, 6, 7, 8, and then the next one, number 9, we'd have to do a different memory adjustment to do that. And then we also need to check if we've moved into a new segment, right? Because there are 3 segments of screen memory. And again, I've got a video on YouTube if you want to know about screen memory. I explain it all like that. But essentially, everything is stored in character squares. And within a character square, you can just go increase the high byte, 1, 2, 3, 4, 5, 6, 7, 8. If you need to go down 1 character, you add 32 to the low byte. And if you need to go into a new segment, then you need to add 8 to the high byte, right? It sounds a bit complicated, and frankly, it is a little bit convoluted. But this simple routine does all of that work for us, right? So it checks, are we in a new character? No, we're not. Have we jumped into a new section? No, we haven't. But if we have, then obviously we need to make the adjustment accordingly. And all that does is just converts the screen so that we can just, it's completely linear, right? Each time we go to a new line, it has to do that calculation, right? Now within a game, you can't, I mean, that's a common routine. That's a routine that I use in AGDX, for example, for drawing the sprite to go down. It's fairly fast. But in, say, for example, Asteroids RX, it wasn't fast enough. And so I just use what we call a lookup table, which says where are we, and what would the address be if I move down 1 line, right? So it takes up more memory, but it's even quicker. And in most of the games that I write, because memory is not usually an issue, I would use a lookup table. But in this case, I'm not messing about with a lookup table. I'm just using this very simple routine that will move me down 1 line, right? Okay, and the last thing that we've got here is this command, which is called DJNZ, right? And it looks like an unusual command, but actually all it means is decrease and jump if not 0, right? Decrease and jump if not 0, and it works exclusively with register B, right? And then here we've got register B, and that stores the height. Okay, so register B, there it is. We have 20, and all it will do is says decrease and jump if not 0. So decrease B, so it'll go for 20, and you go 19, and jump if 19 is not 0, which it isn't. It will go back to draw loop here, and it will start drawing. It will do the next line again, right? And then that will continue. So draw 2 bytes, go down 1 line, and then if B is still not 0, go back and do the next line, right? And obviously then we'll go from 20, we'll go 19, 18, 17, 16, all the way down. And then when it hits 0, then it will have done 20 lines, right? at which point, because it'll go 20, 5, 4, 3, 2, 1. When it's on 1, it will have done 20. And then one more decrease, it will hit 0, and it'll say, I'm done, and then it'll quit. Well, it'll go back to where it originally was. All right? So I hope that was pretty clear. But I will ask you guys, give you a chance. I know there's not many of you here, but you know, bear in mind, some people will be watching it online later as well, those that can't make it. So if you do have any questions at this point about that, then fire away. Or is that fairly clear? I've had the flipping calculator in the way. I hope that hasn't caused too many issues. I really should watch what I'm doing with that, but anyway. Okay, good. Well, it's clear to Andy, so that's good. Yeah, I can review it one more time if you want, but basically, yeah, well, the complicated bit is the complicated bit really is just the Spectrum screen memory, right? That's really all it is. So I'll tell you what I'll do. I'll add a little bit of commentary here so you can see, right? So what we do is DE holds the source code, right? Source for the graphic. So get source byte 1. Well, it isn't really byte 1. Get source byte there, right? Put on screen there. Go to next source byte. Go to next screen position. So it's moved itself across 1. Get source byte again. Put on screen. Go back one step on screen. So back from where we were. Yeah. Go to next source. And then this part, which is a little bit complicated, but it just means move down one line, right? And when we move down one line, it's literally like this. Did we leave the char square? This is what it's doing. No, so we're done. If not, move to next char square. Right there, that's what that does. Okay. And then here, sorry, did we move to a new segment? Well, I should probably put that there. So let's say, right, so we want to know, did we move to a new segment? No. We're done, right? Else adjust for new segment. That's more or less what it does, right? And again, you know, if you watch the video about screen memory, you'll understand it a bit more. That's the bit that's a bit complicated. And then we go here, and this means decrease the height counter and jump if it is not 0. And we'll say jump back if it is not 0. Jump back to the start here, and then it's just going to repeat the same thing, but of course the addresses have all been updated, right? So it'll just go bump, 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 like that, right? Easy enough. So let's assemble that, right? And then you can actually see it kind of running in on the Spectrum, right? We've got no errors, so we'll go to here and let's go show graphic and pause. Right. Ta-da! Right, there you go. And there, I hope you can see, is the wizard. And of course, he is upside down because, as I said, the graphics are all stored upside down and drawn from bottom to top. Right? So, pretty straightforward. Now, what I'll do as well, just to show you that this is easy enough, right? Once we get to the end of the routine of drawing that wizard, where will the source and screen address be? Well, the source will have just finished drawing, and that means it will be here at gwizard down 2. And if it draws gwizard down 2 and then it finishes, it will be at gwizard down 3. So that means that if we want to draw, one of the things we could do kind of fairly straightforwardly is, and it's a bit lazy but it's not a problem, we can just literally just call that routine a few more times, right? Right. Okay, so we'll just, if we put that in there like this, of course we could do a, we could do a loop or whatever, but then we're going to start getting into nested loops and things, and I'd say that's a little bit more than intermediate level. But let's go 1, 2, 3. Well, it's intermediate level, isn't it? It's not beginner level like you guys are, I'm guessing. So that's going to run that same routine 1, 2, 3, 4, 5, 6, 7, 8, 10 times, right? But remember that the addresses in the CPU are going to be updated as it does it, right? So hopefully we do that and you'll see what happens. Right, there we go. Now what's happened is too much, not enough room on the screen. So we've ended up printing too many graphics at once. It's just going down and down the line, right? I mean, what we could do is we could reset it each time after we finish drawing. We could reset it and have them all draw crossways if we really wanted to. But it's only a demo anyway. It's just to show you. I mean, I'll reduce the number of what's the actual number that we can print on screen. So 1, 2, 3, 4, 5, 6, 7, probably 9 before. Yeah, you see these attributes. What's happened is it's got to the bottom of the screen pixel memory, and it started to write into attribute memory, and that's why you're getting these weird colors here. And it may well have even gone over and into the system variables or something. That's why you'll just get this weird crash and everything. So we'll just switch that and we'll just print maybe, is that 9? Yeah, that's 9. Okay. So we'll run that again, and then we'll run that here. Okay, and you see this is where it says nonsense in BASIC. It's not a problem. That's when I said it's just loading. It's just going back to BASIC, but it doesn't know where to go back to because it was never in BASIC in the first place. That's more or less what that means, right? So let me just. I'm going to save this off now as a screenshot. Okay. Just purely a demo for you. We'll go to the wizard and we'll save it like this. And now I'm going to open ZX Paintbrush, which is my editor of choice. Andy can't stand it, but it's just not old school enough, I think. It's just been using too many fancier packages for far too long. Any road, let's see if I can load this in for you. Should be in here somewhere. Just a minute. Uses forget where I store everything on this laptop. There it is, right? Okay, now I wanted to load this in because I'm just gonna grab it like this. Oh, let me just make sure that we're not on screen, are we? There it is. It's this one. Yeah. See, I'm getting better, guys. I'm remembering. Right. So I have to remember to take this away when we're on the source code. Okay, so so we're going to just highlight this, right? And then we'll use the option and we'll just go flip vertically there, and there things are starting to look a little more as we would expect. And I'm going to set the paper and the ink to white on black, and then I'll just turn off the draw option, and then I'll just switch to there, and then if I just do this, I can just make it so that you can see what it is, right? And that's the graphic for the wizard, right? There you go. So it's easy enough, and we can see that that's more or less worked, right? I mean, I'm not quite sure why we haven't got that little top bit there. Maybe there's an oversight in my code, I'm not sure, but anyway, it's more or less right, isn't it? So let's take a look at what Andy sent me, and we'll see what we can do with that now, right? And so what we're going to do now is put in we're going to put in the graphic that he sent me. So here we go. Seems we're only down to just the three of us again. It's a bit of a quiet one tonight, isn't it? But well, never mind. Okay, I've got it now. I just need to move it over to somewhere where I can find it. Okay, bear with me. Okay, and okay, there we go. Now let's just see up and down, left and right. Have we got the right number of frames there? No, we don't. How many frames have you got there, Mr. Johns? We only need 4. We can't be having, well, we only need 3 actually. So what are we going to do about that? Well, we'll have to figure something out. Let me see. Let's just go back to the source code. I know you guys can't see it. Just a minute. Well, you guys don't need to see it right now. I'll just take my word for it, right? We've got okay, wizard down 1, wizard down 2, wizard down 3. Yeah, so presumably okay, so we're going to go with what are we going with here? Let's see, we'll have wizard down 1, wizard down 2, wizard down 3. That makes sense, doesn't it? Okay, so we'll start with those. Well, that's actually wizard up, isn't it? But that's no problem, right? We've got space to do that, right? And then here we'll do the same. So this will be actually down, right? So we'll put that in there. Yeah. Let me just check on here. You can see what I'm doing. Yeah, you can all see it. Okay, 1, 2, 3. Yeah. So I've done the same thing. Basically, what you just said, Andy, haven't I? Okay. So make sure we do these in the right order, because we don't want to have her to move right when she's moving left or whatever. Doing the moonwalk or something. So left is next. Okay. So if we have a left, what will we do for that? Well, what do you suggest, Andy? Should we just go? I'll take these 3. Put that one in the middle. Put that one on that side. And put that one on that side. I don't know. It'll probably look alright, won't it? What do you think? Okay, I'm going to take that as a yes. I'm going to take that yes as a yes to what I've just said. So, all right, and then we can just, we can just do that again, can't we? Same thing again. We just flip it, right? Flip horizontally. There we go. Okay, then we're going to move that down like this. Put that there. The reason I'm doing that is so that we've got all of the data that we want in the right place, right? Okay, so then all we need to do is we're going to export all this data, and so let's what we do is we choose export, and I'm not sure whether you guys can see this or not, right? I choose an assembly. I'll check my windows now to see if you can see this. I think this one, not this one here. Yeah, right, okay. Okay, so what we're doing is we're gonna, this is really the reason that I use ZX Paintbrush, because it has some really nice export functions that you can literally export to a clipboard, so you don't even need to save it as a file, right? So we're going to choose, we're not going to use attributes, we're just using pure pixel data first of all, and we're using block-based output, which is basically tiles, and it's going to be hexadecimal, and it's going to be separated by commas, and it's going to be def B, and it's going to start with a $sign as a symbol, and the tiles or the blocks are going to be 16 by 16, right? So when I get the data out, I'm going to get data for this image, then this one, then this one, this, and this, then followed by those, right? So in all of those cases, it's going to be in the same order that the original game had it as. Okay, and I'm going to export it to clipboard now, and then I'm going to tidy up a little bit. Yeah, it's very easy, isn't it? It's very handy, right? So now we're going to go back to the source code, and we're going to have to make a few adjustments to the source code, but generally we're going to the actual output that we've got, but more or less we should be able to work with it fine, right? So I'm going to go down to the bottom here, right, and just put it in out of the way. I'm not going to keep it here, I'm just using it as an empty space, right, and I'm going to paste it. So that's all my data, right, and each one of these is going to actually be this is GWizard1, right? Okay, so the first thing I'm going to do, because in each case here we know that the height is 16, right? So we haven't got, the height is not defined in the output, so we're going to have to put the height in on each of these ones. Every one of these is going to have to be done, which is a little bit laborious, but shouldn't take too long. Oops. Like this, right? So that the definitions, each sprite has got its own height in the game, right? So that's why we're defining them here, like this. Okay. Another one. I mean, you know, there might. It's a pity that I guess that it could be even more powerful, you know, outputting, but it doesn't take that long, does it? You know, it's just a bit of a pain in the posterior, but it's all right. Okay. So now we've got the data in the format that we want. Then what we're going to do is we're going to add the labels, right? So we're going to have to go back to the wizard. Right, let's find it. Okay. So there's two options for us here, right? One is we can replace the original graphic with the Nixie graphic, or we can put we can add the Nixie graphic and well, I tell you what the easiest thing to do. I mean, well, just to finish, we can add the Nixie graphic into memory if there's enough space, and then we can point the sprite table at those addresses instead of the wizard, right? That would be the other way. But since I've done this before with Saberman, right, we might as well change everything, and so that we replace Saberman with Nixie, right? So for example here, see where it says Saberman, we'll just change that and we'll write NIX, we'll put a Y in here, that's just a Y plus 1 to 8, that's just a marker, right? NIXY, like that. And then this part we don't need to worry about, that just means you have to collect everything. And then yeah, this was another hacker did for Nick Jenkins. So we'll just change it to Nixie there. If you do happen to finish, it will say, instead of saying you have escaped, it will say Nixie escaped, right? And then, so you know what's going to happen, Andy. You're going to be like, oh, let's change all the graphics and we'll put all Nixie and enemies in there, and it'll be like a Nixie game. Yeah, well, you can do that if you want, mate. I'll send you the source code. You know how to do it now. Okay, we'll make the food. Leave the food as it is. So that's not graphic wise. Okay, and it says if Saberman, right, use Saberman left, Saberman right instead of the knight, right? Okay, so that all we need to do then is find where the graphics are. Okay, let's see, is it here? Ah, no, that's the graphic for the weapon, right? We won't worry about the weapon for now. That's not messing about to that level. It's already getting late, so hopefully we can find the Saberman graphic. Where is it? Well, we should be able to find it by just searching for G Saber. Yeah, okay. So these are our labels for our for Saberman, right? So we're going to have to replace the Nixie data with that. So we've got, let me just see, what does it go? It goes down, down 1 2 3, up 1 2 3, left 1 2 3, and right 1 2 3. So that's pretty straightforward, isn't it? Right. So this is what we had, and I'm not going to call it Nixie. I'll just mean some more label changing. So I'll call it Saberman down, Saberman down 2, Saberman down 3, and then we'll go. Sorry, can you guys see this properly? Yeah, you can. Good. Okay. Right, and then it's up. Right, like that. Save amount up. Save amount up 2. Save amount up 3. And then it is left. And left 2. Left 3. And then it is right. This is always, when I do this, I think, oh God, I hope I've only got 3 graphics left, because otherwise I've done it wrong. So we'll find out. I'm feeling fairly confident. I think each one is 3, isn't it? So 3, and that should be the last one, right? See? Yeah, there we go. Good. Okay, so now just going to take all of that, just like that, right? And we'll go to the original, which is here, and we'll just paste it over, right? There we go. Okay. Yeah, okay. And we got it set at height of 16. So that should be it, really. Obviously she'll have a like a sword instead of a I don't know what you would want really, but you know, like a magic ball or something, right? No. Fairy ball or something, I don't know. Anyway, that should do it. And let's roll. Do we get any errors? No errors. All good. Let's make sure the screen is on. Okay, well there you go then. So now that's fine. Throwable sword. Let's see if it worked. It should work, shouldn't it? Let's go. Ah, look what we forgot. Dope, we forgot. Ah, that's funny because basically she's upside down, right? Because we didn't change the graphic. Oh, that's annoying because we already did all that editing. Ay, 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 ay. And that's weird, isn't it? Look, these graphics have changed as well, so I must have done something wrong somewhere. Everything seems a bit out of whack now. I know, I said don't forget to flip it, and I bloody forgot to flip it. Well, look at this. Everything's out of whack. Look. It's a weird Frankenstein there. She's running around upside down. It's just mental. Look at this. Oh, we've really messed it up. Look at that. That's wild, right? Sometimes when you get it wrong, it's funnier. It's funnier than when you get it right, yeah? What's going on here? This is objects, isn't it? This is like the key. That's the key, isn't it? Look, I just picked up the key and it's the witch. Everything's really wrong. Yeah, everything's out of sync, you know? That's why. I've just put everything out of sync. So, yeah, it's ready. It's good to go. There you go. Just turn you, just stand upside down while you're playing, you know. Alright, well, I feel kind of obliged to fix this, really. Time is kind of ticking on, but never mind. We can fix it. Okay. I hope so, anyway. I mean, we've got the graphics, haven't we? So we can just. I wonder how I got that wrong, though. I must have just missed something out somewhere. Okay. So we'll go back to what it was. Unless. Oh no, we have got save man switched on. Right. Well, let me just test it and see if. Oh, I've got an error there. What's that? Right side of device. Ah, frustrating. Just a minute. Oh, it's because we got the data at the bottom of the screen. That's why. I pasted that bit at the bottom. That's why it was causing a problem. So anyway, we better let's check if we've got Saberman and everything's back to normal, and then we'll just do it again quickly. I'll do it as quick as I can. Okay. Just make sure that it's. Yeah, you see, look, the bug is there still, isn't it? So there's something actually wrong with it in the code, and I think, yeah, what I'll do is we'll just go right back to the very start. I've just undone everything there, and we'll just make sure. I think what it might be is maybe it doesn't like to have them both on. Let's just check if it works now. Somewhere along the line, something got added that shouldn't have been. No, it still doesn't like it. So there's something wrong with the Saberman option in the game. It's not the end of the world, right? Because what we'll do is we'll just change, we'll turn Saberman off, right? And we'll put the graphic in for the wizard instead. Shouldn't take too long, I don't think. It's pretty straightforward. Same principle, really. Okay, just a second. Are we back? Are we back to normal? No. Oh, I probably need to assemble it, right? Let's make sure. I've broken it. It's totally broken. Don't know what I've done here, but anyway, let's see. We'll try it one more time. Seems like I've totally broken it. Oh, whoa. No. I know what I've done. Remember, right at the start, I changed this, didn't I? Attic Amigos. Right, so actually, I rewound it right back to before I even changed this, so that's not the right version. So we'll just go here and we'll say Attic Nixie, for example, right? And we'll just create that instead, and then we'll just test that. That should be okay. If you look in here, it should have appeared. There it is. Right, okay, we're back to normal. Okay. Okay. I think you're the only one left, Andy. I think everyone else has given up, but you're a good lad for sticking by me. Right. What do we need to do? Let's do this quickly. Let's go to... let's bring this up. Okay. And we're going to have to do these one by one like this, unfortunately, just the way I've done it. What we can do, right, is we put it this way, like that. At least this way, if we need to edit it or anything, we'll know. Just be easier to flip, won't it? Put that in there. Flip this one. Well, I had a long day today, I've been moving stuff into a new flat, and as you can imagine, it takes bloody ages. Yeah, so that's easier. That's just, if you were editing, then you just need to remember to do that, right? And then we can just highlight this, and it's the same principle as before. And I will export, and I don't need to change any settings. I'll just do this quickly. Okay, just work super quick with that. Last time I was explaining everything, so I don't need to do that this time. Export to clipboard, and we will go to here and take the window away. Yeah, well, the thing is, my wife's got this project at work, and she's so busy, and she's working at the weekends and everything, so she just doesn't have any time. So we haven't had any time to to figure stuff out. And the other thing is that well, we've got so much junk in our house. I'm not kidding. It's a nightmare because when my school closed, I had to move all my school stuff into the house. And well, it's a bit of a long story, but well, what happened is I live in a small flat, right? And then we got married and we were gonna move to a bigger flat, and then the COVID happened. So she moved in here with me with all her stuff, and it was really packed. And then about 3 or 4 months later, my school closed, so then I had to move all my school stuff in. So I've got all her stuff, all my stuff, all the school stuff, all in a 1-bedroom flat. It's all massively piled up. We've put a load of stuff in the balcony and various things like this, but it's a right tip. It's a bit of a, not a tip really, but it's very, very cluttered, and I absolutely don't want to tell the landlady that I'm moving out until I get all that clutter and deal with it now. It's just got to be dealt with. We thought that it was going to take a while to find a flat, but we found a nice one quite quickly, so we bought it, and then we just said, right, let's go. So that's what we did. And yeah, that's it. That's the long and the short of it, and that's why it's taking a while. But we decided just to be chill about it. We thought we might have to pay rent for another month or whatever, so we're just going to do it, and we're not going to get stressed. And she's got all this work on and everything else. So yeah, I've just been organising everything really between teaching and doing other stuff, and little by little, yeah, we're kind of getting there. And then we're going to get the reason is that because there's so much clutter, it's impossible to get a cleaner in or something like this, right? We want to get a cleaner in before the landlady comes, so that we can just figure everything out, do it all, you know, professionally and respectfully and everything. So that's why we're doing it like that. Okay, and we've got David here now. Hello, David. Don't need to teach you anything. He's taught me everything, to be honest. Okay, so that's Attic Nixie, and this is our exported graphic, and we need to do that same thing again, where we're going to have to put the def B and the height in here. I'm going to have to do that for every one of these. Right, so this, otherwise we'd have to copy each one of these individually into the wizard graphic, and that would also be a bit of a hassle. So right, but it doesn't take that long if I do it quickly. I got a little game I wanted to play as well at the end of the stream. If you guys are sticking around, then I might do that, just for a bit of a laugh. A crappy basic game, but still do like those sometimes. Okay, so that's our wizard, and what is the label for the wizard? Gwiz, gwizard. Yeah, sorry, it's easier to see now. Right, gwizard down. Gwizard down 1. Right, okay. So it's down, up, left, right. So it can work pretty quick if I put my mind to it. Okay, so that's gwizard down 1. That's gwizard down 2. Gwizard down 3. Gwizard up 1. Good. Gwizard up 3, and then it is what? Left. Yeah, so for those of you, or for you who have, the one who has joined recently, which is only David, I think. I don't think it's anyone else, but for those who have arrived late, the reason I'm doing this so quickly is because we've already done it once, and I explained what I was doing, and we messed it up somewhere along the line. So something wrong with the old code that I had for the Saberman mod, which was silly really, but that's done. Okay, and that means we should be able to take all of that. Okay, and then we should be able to just cut it out so that it doesn't cause a problem. And gwizard. So this is if it's the Amigos, right? And then we need it. We don't want to do that one. We want to do else. This is gwizard down. This is the original. So we'll copy over the original and we'll just paste over that with this graphic, and that should work, I hope. And if it doesn't, too bad, because I ain't doing it again. But you know, it feels alright to me. Here's hoping. Okay, no errors, always a good sign. And let's see. Hooray! Right, we've got a wizard, which is good. Now, let's do a little mod. We're looking for the wizard. There it is. Wizard and Nixie. Yeah, that must be a Y. Plus 128. It's a bit marker, bit 1. Sorry, bit 7. Just to tell that it's the end of the line. That's all that is. That's just a little extra touch. Why not? And that will work. And then we will go to here. And I don't think, did I assemble it? Maybe I didn't. Yeah, maybe I didn't. Let's see. That's weird, isn't it? I don't know why that isn't working. Oh, look, it's in the Amigos settings. Duh. Silly me. So it's actually if Saberman, if Amigos, else. Keyboard Kempston cursor. There it is. There, that's the wizard there. That one. Mix. Right. That should work. See comments. People telling me what a fool I am for making such schoolboy errors, but there we go. The joys of assembly indeed. There you go, number 5. We can now be Nixie. Hooray! Finally. And let's test it out. Here she is. Yeah, there we go. Up and down. Oh, something's not right with the down, isn't it? Look, is there something wrong with the down? Oh no, it's okay. For a minute, she seemed like she was... She seemed like she wasn't going... wasn't facing down properly. Didn't say going down properly. It sounded a bit rude, but... Yeah, it was just for demo, right? But it works, doesn't it? So... It's all good. Ah, Stuart, you're still here, my man. Nice. Okay, and you know she's got that little thing there. Okay. Now let's do this, and what should we do? Well, I tell you what I'll do. I'll send it to you directly, Andy. And if you want to put it on a Dropbox for everyone else, that's fine by me. Of course, it is copyrighted, but I don't think anyone's going to complain too much. So yeah, it's just I'm not logged into Dropbox on this machine, so it just get a bit complicated for me. So. But I am on Facebook, so I can just send it to you now. That will do. And then you can Just bear with me. There you go, the magic of the internet. Right, there you go, Andy. So you should receive that now. And if you want to put that in a Dropbox, you can share it in the chat, and then the guys can. I doubt that David's going to be too bothered, but I think Stuart might like to have a little look at it. You know, David's been there and done all that, haven't you, really? Cool. So yeah, that's how you can modify a source code. In this case, Ultimate Play the Game. You need to understand how the graphics are stored, but because it's a source code, it's a lot easier to modify because you're not because you're assembling it, right? So everything's relative, and it'll move things up and down and put them in the right place for you. So obviously the Nixie sprite was a different size to the wizard, but you know, it all worked out. Yeah, okay, no problem. Stuart, great to see you. I mean, to be honest, I'm not going to be here much longer either. In fact, I'm even thinking about finishing even now, but since David's only just turned up, I might stick around just for a little bit. Okay, guys. Well, who have we got? Is it David and Andy? You still here, boys? Yeah? Should we play a game? We were playing this game the other week. Pop Quiz 85, right? It's a proper. I think I've got my settings. I'm allowed to swear. It's shit, but it was quite fun. Oh, Ro's still here. I'm sorry, I didn't know. Have you been away and come back? You've been very quiet there, mate. But I hope you've been enjoying it. Right, we've got. There's a pop quiz, or there's this Commandos game, which is like it's a French game that I found, and I translated it into English. And I think David, Andy, you might be in the game as well. I'm not sure, but yeah, you have to infiltrate this castle, and it's. I don't know. I just kind of liked it because it was so obviously just made by one person and just some kid who just. And it's quite an ambitious game, you know, for a kid. I'm pretty sure it was a kid, and so I kind of liked it. But we can see that, or we can do that another time, or we can do the pop quiz, whatever you like. What do you prefer, guys? We could just do one round of pop quiz if you want. That's perfectly fine by me as well. It's me versus the stream for one round. I quite like the idea of doing that at the end of the stream each time, right? This is the Commando game. I'll just show you it quickly anyway, right? Okay, right. I really do think that this game could have been something quite good, you know. So yeah, well, okay, I'll show you it, right, and then we'll play it again another time. Overambitious basic games, yes, just love them, don't we? This game is really good. I promise. I shouldn't say that. It's not really good. It's charming. I personally find this game to be very charming, but I'm slightly worried that it won't like 128k. So just to be on the safe side. It's a shame we don't get to see that loading screen because it's very amateur. Let's switch the sound on as well, right? My computer cannot handle the high frequencies. There's something really not right with it, as I said. But okay, there we go. Look, Andy Johns is in the game, and so is David. Right, so you have to pick. I don't remember how many players you have to pick. I think you have to. It might be 4, right? So you got to pick 4 players, and different players, different commandos will give you different options that you can do, right? So for example, The locksmith, obviously, he can open locks, and the explosives guy can set a bomb. And the mountaineer, I think the mountaineer means that you can climb the walls of the castle with a rope or something. Pretty sure that's what it is. I've no idea what the diver is. It says David Sapphire, diver. Hate swimming, yeah. Muff diver, that's what you are, David, isn't it? Boom, boom. Anyway, so let's go. I don't know. Every time David comes on the stream, I just turn back to schoolboy humour. I think we're going to have to pick David and Andy. Right? We've got to. Otherwise, there's no point, is there really? So who are we going to pick? Shall we pick Jim Lemon, the commando? Jim Bagley, the code breaker? Appropriately enough. Or... Okay, we're going to pick the code... we're going to pick Bagley, right? Bagley's in. Oh, it's only 3. There's 3 of you. Right, okay. Next up, what are we taking? Diving gear, 25 kilos. 10-meter rope. A rifle, submachine gun, box of cartridges, case of dynamite, grenades, heavy machine gun. Right. What are we doing? What are you picking, guys? Diving gear. Okay. Available weight 100 kilos. Right. Okay. 1 diving gear. It's done. 10-meter rope. Done. 70 kilos. We'll probably take a couple of ropes. Let's take at least 2 ropes. I reckon we need some guns though. Surely we need guns. Got to take guns. What we taking? Dynamite. Where is dynamite? No, case of dynamite there, right. Okay. Dynamite. Okay, we'll take a few cases of dynamite. Here we go. Let's get some weapons, right? Let's get a rifle. And a box of 100 cartridges. And some grenades. We can't take a heavy machine gun. We'll take a submachine gun. We'll take one of them. We'll take another rifle. Then we've got a weapon each. Just what you see, buddy. Just what you see. Okay. Hey, just what you see. Okay, so I think that'll do, will it? Have I got everything? I might as well make sure we've got a radio. I don't know what you do with the radio. I really should save a snapshot because honestly you die so quick in this game, it's a nightmare. So let me do that. I'll save it just because otherwise it's going to be too much. Yeah, I've grabbed a few grenades. I don't know if you can get over encumbered, so to speak. You know, so over encumbered is like a word that you only ever learn from playing like Skyrim or Elder Scrolls. Yeah, you are over encumbered. I'll save this off. Okay. Well, we've still got 17 kilos, so we could grab a couple more grenades, right? I remember in this game you've got to react really quickly, and I can't remember what the keys were, but you go in a room and then it says like the enemy is in the next room. What do you want to do? And then you've got to run to run away, and hopefully you run to a room where the enemy isn't, or you have to fight them. And you know, all in all, it's quite well done. I mean, it's graphically and everything else, it's not, but the concept actually is I think really good. So. Let's get another box of... we'll get more cartridges, right? We'll just get loads of them. I'd take absolutely tons. And a few more grenades. Right? Okay, that'll do. Okay. Here is a plan of the Black Mountain Castle. Should I do a voice? Yeah? Should I do a voice? Okay. Here is a plan of the Black Mountain Castle. Where do you wish to deploy your team? Okay. Shout out, guys. Looks like if you're a diver, I think you can go in in here too. But and if you haven't got a diver and you do that, I think you just die. So, but we have got a diver. Okay, David says 6. All right then. But Andy says 3. Okay, I'm going to press 6 and 3 together, and we'll see where we end up. I don't know. Here we go. There is no way forward here. You must find another route. Okay, so I don't know if that was 6 or 3. We'll try 3. Oh, okay. You are in front of Tower 2. What will you do? Return to the map or scale the castle wall? I think we should scale the castle wall. We've got a rope, right? Do you want to make use of a rope? You do, because I think you almost die if you don't. Yes. Okay, we're in. Here we go. Which direction will you go? Left, right, or inside? First one to call it gets it. Left, right, or inside? Inside. We're in. Inside. Dum 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 dum. Oh, it didn't give me a choice then. Which direction? Oh, 1, 2, 3, 4. Right. Okay. You're in room 6. Which direction will you take? 1, 2, 3, 4. Dum 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 dum. Yeah, I know. That's what I said. I would have loved it as a kid as well. This is why I translated it from French, because it was. I actually think it's a really good game. So 2. Dum 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 dum. You find yourself in room 12. Which direction will you take? You see what happened in a minute. It'll say like there is an enemy approaching, and then you've got to like run, or you can fight. And if you fight, you've got to react quickly, and you've got to choose your weapon. And I think the weapons, like the submachine gun, is faster, and the rifle's more accurate, and it's some things like this. It's really like quite advanced, really. The door is locked. Do you want to use explosives? Shall we use explosives? There's a risk that you die if you do, but I guess in for a penny, right? Let's do it. Oh, the door is booby trapped. You are killed. That's the punishment, right? Okay. Damn. Next time, we're just going to cheat with the snapshots. I don't care. Right? Let's go. Okay. Black Mountain Castle. We're in room 3. We'll follow the same rules. I don't know if it's random or not, but front of Tower 2. Yeah, this is where we were. What will you do? We will scale the castle wall. Yes, we will use a rope. And then we'll go inside. Yeah, I told you it was good, didn't I? Right, we're going inside. Right. And then I went 3. Yeah, this is where we were. Right, okay. And then we went, what, 4 was it? This door is locked. We'll use some explosives. Now, I don't know. We might be a bit stuck here, but we'll save it here and we'll choose no if we die. I don't know if it's random, 50-50, or if the it might just be that the randomized seed is set and you always die if you use the explosives, right? So, no, we did it. We blew the door. We're in. Okay. You are in a corridor between rooms 5 and 6. 2 directions are available. Which will you choose? I like how he's got this. Look at what he's wearing. He's got a kind of shoulder revealing top. You know, it's like a woman's top, isn't it? Anyway. Okay, 1 or 2, guys. Which one are we doing? 1 or 2? It does look a bit Star Trek. You're right. It does, but wrong colours. But the boots. Yeah, the boots and the trousers are very Star Trek. Okay, we're going for 1. Right. I kind of feel like I should be saving it at every turn just so we can so that we don't have to keep going back, because that is a pain. That is not suitable for stream. Right, we're going in 1. Oh! The door was booby-trapped. A bomb went off. Game over. Right. No, game not over. We're going to room number 2. First of all, though, let's test the game and see if it's always going to kill you. Yes, it is. It's just one of those things. It would be so annoying, wouldn't it, in the real game, but you would still enjoy it. Right, we've gone to room here. I want the enemy to turn up now. That's the next thing that's exciting in this game. Okay, where are we going? By the way, what we have to do, there's a mission. It did mention it right at the start, I think, but I skipped it. You got to find the secret papers, and then I think you've got to get out. Right. You notice there's 3 of us, but there's only 1 man. But there you go. Let's go. We're in room 5. Andy says 2. We're going for 2. An armed group of 3 guards are 7 meters away. That means they're very close. Quickly decide, confront them. Right, confront. They're 4 meters away. Prepare for combat. The weapons are submachine gun, rifle. Let's bomb them. Oh, you've waited too long. They've burst in and they've killed me. That was my bad. I made a bad mistake there. Right, we're going in here. See, you've got to react quickly. When the enemy arrives, you've got to react quickly and choose what you're going to do. Let's see. 7 meters away. And by the way, the meters is like how long you have to choose, right? We'll confront them. Prepare for combat. I'm just going to... There's 3 of them, right? Let's blow them up. Oh no. Another patrol has been alerted. Right, 3 guards, 21 meters away. That means we've got a bit more time. We can run. Not very brave. No, but we ran away. Okay. I don't think you ever get to see them. But anyway, we'll continue. Right. Okay. Where are we going? 1. I think that's where we just came from. 1. You want to go back and fight them or something? Okay, we're all right. They've gone away. Save. Okay, I'll save. Yeah. All right. You find yourself in room 9. Okay. Trying to build up a picture in my head of where we are, but we'll keep going this way. Room 4. Those rooms there, 2 and 3. Yeah. Rooms 2 and 3. Let's go for... What do you say, guys? We'll make this interactive. What do you want? So 1, I think, is where we came from, right? So 2, 3, or 4. It'd be good to hack this, couldn't you? You could hack it and then make it into like sort of an alien game where aliens are approaching and you can... Yeah. Okay, we're going for 3. Okay, just in case it's a bomb, I'm gonna save it again. 3. Here we go. Okay, this is room 9 again, right? So it looks like if you go from 3 on room 9, you end up in room 4. And if you go 3 again, you end back up in room 9. Yeah. So should we go for room 2? I mean, you know, direction 2. Okay, this is room 10. Where now? Told you it was a good game, didn't I? Right. Like you said, as a kid, I would have just loved it. Would absolutely loved it. But you do get these random deaths, which is of course par for the course in a way. But okay, 2 again. I just saved it, so we're doing all right. Oh, we're back in room 9 again. Right. So 3 to this is room 4, and then we went to 3, and that took us to room 10. Is it? No, we're back in room 9. Right. Okay. So we'll go there. Okay, now we'll go to room. Let's go in the door. The door is locked. Use explosives. That's always a good thing. Save it and explosives. No. Don't. Use explosives. No. Right. Maybe it's a permanent problem. I'll try it one more time. Seems like 3 times, I'd say. If it happens 3 times, it's stuck, isn't it? That door is permanently booby trapped. But it might not be. No. Choose another route. It might not be if we go out and come back in again, mightn't it? That's always an option. Room 5. We're back in room 4. The door is securely locked. Use some explosives. Tell you what, I'm using a save state again. Yeah, I think that room is just not accessible, so we won't go there. Where are we going then? No explosives. Choose another route. Right, we'll go. Is this room? We're gonna try and get to room 10 or something, right? Was it? Okay, this is room 10. I think room 10 is a good place to save it. No, not load it. Oh. Don't. How did I get to room 10? Was it here? Not so far, no. It should be a locksmith. You should be able to pick the lock. I think room 10's a good place. Right. Let's go from room 10. Well, let's see, where do we end up if we go this way? That's okay. 4 guards. Let's fight them. Come on. 22 meters. We will confront them. Prepare for combat. I think we should bomb them. No, we'll use submachine gun. Now that was fucking brilliant. Look at that. We've killed them. Notice that they've got a slightly different uniform. They've got red. They've got red, a red top and the green pants. You know, but the red shirts always die first, don't they? That's just like Star Trek. Okay. Imagine if that body stayed there for the rest of the game. That really would be classy, but I don't think it is. But we're in room 5. We can go to room 10 from here. Right? And then this, if I go, I better save it again. Yeah, all got the same boots, yeah. Right, room 10 takes us back to 5 guards. Right, come on. Machine gun them again, I say. Or rifle. Or bomb them. Oh, don't use the bloody explosives. Or maybe 11 guards. Oh my god. I wonder what happens if you try and hide. They have entered the room. What will you do? I don't know. Has it crashed? Stay hidden. Try to run. Attack them. Let's stay hidden. They did not see you and have left. That was a lucky break. Hey, better a live rat than a dead lion, David. You know? Okay. We're not getting very far, are we? Come on. There's got to be a way through secret passage or something. Right, let's go. This door is securely locked. Oh, come on. No, I can't use explosives. Although this door did work, didn't it? Yeah. Oh no, I pressed escape. Oh, look. Break into program. Can I continue? Maybe I can. That'll be ace if I can continue. Yes, I can. Brilliant. Break repeats. Right, now what I was trying to do then was I was trying to bring up the emulator options, you know, to save it again. And on Fuse you press escape, I think, to bring up the cursor, right? So okay. Right, I've saved a snapshot. I'm going to try and blow up this door because I think this door will blow, right? Yes. Okay, now save it, right? Oh, look at this. Now this is good. Save it again. Okay, I love that. How we press break and we just continue. 1 or 2, guys. Where are we going? Up the stairs this time. We're going upstairs. 1 or 2. 1 is trapped. You sure? Okay, yeah, I think you're right. Okay, we're upstairs. Are we? Room 6. You see, it looks like you can climb up by going to room by pressing 1, doesn't it? But I don't know if that is the case. There must be some logic to all of this. I haven't looked at the code that closely, really. I just went through and translated it. It loaded fine into Basync or Basin C, whatever you call it. Oh, this is new, isn't it? Room 11. I think room 11 is new. Room 12. Oh, look at that door. That looks like a pretty fancy door. Right, let's go. Room 3. Okay, we'll choose use some save state. I did bring quite a few explosives, right? Oh, I do wonder if that is random or what, because I mean I think it is different every game. So looks like some doors are just always every time. I mean I don't know if it is every time or if it's just a random seed, you know. It might be that as well. But I think we're going to have to go for room no explosives then. Let's go to room 2. Where have we ended up? We're back at room 11. That's no good. I'm just properly cheating now. Like this. Back in room 6. Oh, okay. So that's up the stairs, right? Yeah, and then let's go up the stairs again. Is that what we did? And then we ended up... Oh, look at that. Rooms 10, 11 and 16. Well, I don't think we've ever been to room 16. So let's try 3. We want to get to room 16, don't we? An armed group of 3 meters away. That means immediately react. Confront. Prepare for combat. They're 2 meters away. Each time that it goes down, you've got to pick it in time. You are unarmed, so the patrol mate. Sorry, but you are finished here. That was my translation that I added there. A little bit of the old Operation Wolf, just for fun. Didn't really say that in the translation. We've run out of machine guns, so we're going to have to use the rifle, aren't we? Right. So where were we? We want to go to 3. And there are 8 guards 3 meters away. Hopefully we can get away with this. Confront them with a rifle. What? You are on a... What is going on there? Because... Have we used up all our bullets? But I thought I bought loads of bullets. I think that's a bug, yeah. I'm going to hide though. Perhaps we'll get away with it, right? Oh no, come on. Yeah, I'll hide again. I've tried to run. I pressed 2 because 2 was hide in the first example. I hope you enjoy my translation. It's kind of fun. They cut you down in a hail of bullets. Right. Guards. Hide. And then more turn up, right? Yeah, right, okay. And then we'll try and hide again. Right, now we'll see if we can get away with this. Yeah, take your time, game. Go on. What are we doing? Does it mean want me to press a key? Stay hidden. Wow, we got away with it. Right, save. I didn't press escape again. You have to press Alt. Save. Right, where are we going? Room 16? Good, we're in room 16. That's good. Let's go to... What do you think? Well, we just saved it, didn't we? So what's 1? Is it upstairs or is it back? I think it's back where we were, isn't it? Yeah, we won't go that way. I'll just load it because I don't want to risk more soldiers turning up. 2. Locked. Explosives, yes. Yes, good. Good. Wow, look at this. Well done. You have arrived. Oh no. What is this? Oh no. I just realized, right? Yeah, you've got to find there's a piece of paper, right, somewhere else in the mansion, and you've got to find it. And that has the code, right? And oh look, that's a bad translation. Look, I haven't done it properly because it says clavier. You can see a clavier. Please enter the code. But we don't know the code, and I bet we die if we enter the wrong code. Alas, you have failed with victory so close. Perhaps you will fare better next time. Well, listen, guys, it's getting pretty late. We did have some fun with that, though, did we not? I think we'll leave it there. Oh. Yes. Death has come calling. Death has come calling at the Black Mountain Castle. Your best was not good enough. Would you like to have one more try? I told you it was good, didn't I? I told you. I'm really happy that you guys enjoyed it as well, because I do like... There's some real little hidden basic gems, you know. I imagine that this game was written by this one guy, Eric Chosiel, whatever his name was, I can't remember. I tried to see if I could find him on you know, Facebook or Google or whatever. And I think there was one guy, and he's like I don't know, insurance salesman or something now. I don't know if it's the same guy, but it'd be funny if I could contact him, wouldn't it? But I imagine that he spent absolutely hours and hours writing this game, you know. I mean, I don't know if you guys did that, but I spent hours coding in BASIC, and you know, hats off to him really, because it is, I think, for the time, it's really quite a well advanced game. Except, of course, without the save states, it is a nightmare. It is a nightmare. But with the save states, it's probably quite good. Yeah. So yeah, the objective is that, as far as I remember from the text, you have to find there's a piece of paper in one of the rooms, and it has the code on it. But there really should be an option, like when you get to the safe room, where you say, "I don't know, we'll come back," right? Because you shouldn't just be like, "Oh yeah, I don't know the code," just random. That shouldn't be. That isn't fair. You should be able to go back. So yeah, David, if you want to, I'll send this to you, and you can have a poke about with it in the BASIC. Perhaps you can make a few amendments and changes. I don't know, but I think it's a winner. We had a good laugh with that, didn't we? Right. Cool. Well, let's finish up there, guys. It's gone on a bit longer than I thought it would, but it was fun. We did a bit of coding, we did a bit of gaming, and yeah, it's wow, 2 hours 45, but great fun. Okay, guys. Well, take care, and for all of you watching, the few of you watching still on the recorded version, well, I hope you're having a great day. Take care of yourselves, and as always, happy coding. Bye bye.